Hello everyone, welcome to Devjit Decodes. So in this video we are going to talk about a little bit about the graphs. That is the introduction part, some terminologies and some representations and all these things. So before this, let me tell you, because we have solved so many graph algorithms so far. That is, one is Dijkstra, Prim, Kruskal. We have seen graph algorithms, we have seen the shortest path concept and all these things. That is in greedy approach. So I thought before going to some other graph algorithms, that is, we'll be seeing some dynamic approach, for example, Bellman-Ford, then we'll be also solving say Floyd-Warshall and maybe much more. Okay. So before going to those algorithms, I thought it would be a good idea so have some clear-cut idea about some terminology. This would be a very much beginner-friendly kind of graph introduction, you could say, because I will be having a separate dedicated playlist for all the data structures. There I'll be talking about array, linked list, tree, graphs, everything. But here, because we are talking about some graph algorithms to solve, say, in the greedy approach or dynamic approach, so I thought let us just have a quick discussion about some terminologies as well as the graph representations. Suppose this is a graph given. Okay. Now, if you can see, this is a graph. Okay. First of all, what are the examples or say what are the usage of a graph? Say if you can see this particular thing, these things are called as nodes. This is the node A node, B node, C node, D node and all these things. Also known as vertices. Vertex is a single form or vertices is a plural form. So if you want to see what are the vertex, A is a vertex, B is a vertex, C is a vertex and so on. And the thing that connects two vertex are known as edge. So this is one edge, this is one edge, this is one edge, this is one edge and so on. So edge is what? The line or the path that connects two vertex, right? Now, if you have understood this particular two concepts, I hope majority of you have already known this thing. Now, if you know this, let us come to the application, because graph is one such data structure that is used almost everywhere. One of the biggest and most beautiful data structure. So now, if you want to see the real life, let me talk about the real life stuff so that you get more motivated to work on graphs. Suppose say social media. So you are using a social media app, say Facebook. Now whenever you are using Facebook, say you have sent the friend request or your friend, say this is a person who is this particular age is saying that this person A is connected to B, or say this person A is a friend of B. Now this person A is also a friend of C. Right. Now if you can see, A is a friend of C, C is a friend of E, but A and E doesn't have any direct age connected. So A and E are not friends. Now if you see Facebook, you can see that you get recommended that this is a friend suggestion, this is a friend recommendation. From where it is coming? It will be coming from this particular graph. Because if C is a friend of A and C is a friend of E, it would be suggesting that he is a mutual friend. So A and E might be, you two might send a say friend request to each other, right? So the more the mutual friend, the more there is a chance of you two knowing each other. That is the meaning of this particular thing. Next we go for Google Maps. If we see in say we are rigorously using Google Maps. What is this? Suppose this is a source node. Suppose this is the particular area from where you are starting your journey. And you want to reach E or you want to reach F, anything can be a destination. So if you put in the source part and if you put in the destination part, then we can find out in which way we can come to make sure we have the less amount of time to travel or we have the less amount of kilometer to travel, right? So this is one another big application of graph, Google Maps and all these things. Okay. Now let's just see other terminologies. For an example, vertex is done, age is done, we have connected A and B, this is an age, this is an age and all these things. Now what is degree? Degree is nothing but a particular vertex is connected to how many vertices. That is how many edges are coming out of each vertex. So if you can see A, the degree of A is equal to 2. If you see C, C is connected to D, E and F. So the degree of C is nothing but 3 and so on. Right? So can the degree be 0 of a particular vertex? Because if you see this graph, it might look like that everything, if you see F is only connected to one vertex. Still, the degree of F is 1. So can this be 0? Let it be in your mind. Okay, I will be coming whenever we will be talking about everything. This will be cleared it out. Now let us go to cycle. What is a cycle? when you start from a particular node and you come back to that node, that is when you start from a particular vertex and that is the starting vertex and the ending vertex are same, that is called a cycle. So if you see, if you start from A, B, D, C, A, if you follow this, A, B, D, C, A, B, D, C, A, it is starting from the same node or same vertex, it is coming back to the same vertex, and this forms a cycle. This is a cycle. This is a cycle. Again, if you see C, D, E, this is also a cycle. C, D, E, C. So C, D, E, C. This is also a cycle. Right? Now, what is connected graph? Connected graph simply means when all the vertices can be reached from one to another. That is, if you can see, if you want to come to F, so if you want to come to F, it can be reached from anywhere. You want to come from A to C to F, or A to B to D to E to C to F, you can come via any path. So when all the vertices are connected via a single line, it's not that there has to be a path from A to F. It's not like that. It's just that you need to reach to all other vertices from any vertex. That is the concept. So if you see this graph, this is a connected graph. This is a connected graph. That is the meaning of connected graph. What is the meaning of disconnected graph? That is, some vertex may be isolated. If you want to see, suppose a disconnected graph, say this is A, B, C, D, okay, and there is a vertex E, but it is not connected to anyone. But this is a graph. This is a graph. This is a graph. Might be, you might think this is an island. In a country, this is an island. It is not connected directly. There is a sea. There is sea in between. You can think like that. You can imagine like that. So this is isolated. So in that case, this is known as disconnected graph, because all the things are not connected. Why? This is suppose train line. These are train lines. So these all the vertex are connected by train lines, but there is sea in between. There is no train line. So in that case, via train line it is not connected. You can think like that, right? Now I am going back to this particular thing, degree. As I have talked about this just 2 minutes back, that can the degree of a vertex be 0? The answer is yes, because here the degree of E is 0. It is not having any outgoing or any edge associated to it. It is not connecting to anything directly. So this is the meaning of, say, disconnected graph, and that's why there can be a degree 0, right? Next is undirected graph. What is the meaning of undirected graph? If you see this particular graph, is there any direction? Is there any arrow given? Up arrow, down arrow, left arrow, right arrow? Is there any arrow given? No, right? So what does it mean? Simply, this particular thing simply means if A is connected to B, if A is connected to B, as I have said for in case of social media, in case of Facebook, if A is a friend of B, then obviously B is a friend of A, right? So this is the meaning of it. It doesn't need a direction to say. If you see this particular thing, if you only see A and B, say Amol and Bimol, you can simply say if Amol is a friend of Bimol, then Bimol is also a friend of Amol in case of Facebook. Now, then what is the meaning of directed graph? Directed graph simply means there will be a direction. There will simply be a direction. For an example, say there is a direction given. There is a direction given. There is a direction given. So A is directing to B, that is A is kind of, this particular thing is given, and C is this particular, that is all the edges are going towards B. So what can be a real life example? As I have talked about in terms of Facebook here, we can talk here as a directed graph in terms of, say, Twitter or Instagram. What is that? Suppose say this is you, whoever is watching this video, and this is me. This is you and this is me, right? Now, this is VK. What does it mean? You and me both are following Virat Kohli in, say, Instagram or, say, Twitter. But that doesn't mean that Virat Kohli is also following us, right? If this is this, this simply means that if these two are like this simply means that the Facebook concept, that if you and me both are following, both are kind of friend with Virat Kohli is also kind of sent a friend request. But it is not like that, right? It is a one-way path. We are only following him, right? So that simply means that you and me are following Virat Kohli. and all these things, right? So this is the meaning of directed graph, right? So there is, you cannot say if that is both directional, then in that case, suppose it is, say it is Anushka Sharma. So in that case, it is both directional. It can be both directional, no problem with that. Okay, but if it is single directional, that doesn't justify that you can say the reverse way as well. So that is the meaning of directed graph. Then there is weighted graph. What is the meaning of weighted graph? Weighted graph simply means there is a weight associated. Suppose from C to F, because here there was no concept of weight, there was no concept of age weight, there was no value given. Suppose C to F was 50. This simply means, say, weight is used for what? To find out the cost, to find out the minimum cost, minimum value, and all these things. So weighted graph simply means to from C to F, to reach from C to F, you need 50 unit of time, or you need, say, 50 kilometers of travel. So this is the meaning of weighted graph. So each value, each age will be having some weight. Say 50, then 70, say then 80, then 90, and all this thing. Now there is also, because as you can see, we are giving the positive weights here. But while discussing about the Dijkstra's algorithm, which is available in our playlist, I have talked that whenever we will be coming to Bellman-Ford, before that I will discuss there is a concept of negative weight as well, minus B. So what is minus B? Because if you see, if there is no weights, that is unweighted graph. First, let us discuss about this one. Whatever was there so far, there is no weight given. It was like this. It is an unweighted graph. There is no weight given. But whenever some weights will be associated between two nodes, between each, that is on each edge, some weight will be associated. In that case, that becomes a weighted graph. That becomes a weighted graph. But the weight can be negative as well. Weight can be negative as well. What is the negative weight concept? Say, because I have said in case of Dijkstra that Bellman-Ford will be using the concept of negative weight. Dijkstra is failing for negative weight. What is the negative weight? I have said that whenever I will be talking about Bellman-Ford, I will be discussing it rigorously. But let us have a look now. What is negative weight? Suppose, say, this is uphill and this is downhill. So whenever there is a, suppose say there is a train which runs by the battery. So whenever this train is traveling from this route, say from, say, this particular thing, there is a direction, this route, okay, suppose say not like this, suppose write one edge only. So this route, directed graph, that is, it is coming from the downhill to uphill. Suppose there is a train going from downhill to uphill. In that case, if it is written 20, what does it mean? Suppose the train was charged, the battery was fully charged at 100. So initially here, that charging point was 100 when the train started. But when it reached the absolute uphill, it has kind of, taken up 20 amount of charging. So the charge remains at 80. Charge remains at 80. This is the meaning. Now, suppose there is a technique that has been discovered that whenever you are coming and you are coming downhill at a hill station, you are coming at a downhill at a hill station in this direction, there might be a chance that the battery gets automatically charged up. So suppose now you have again, it was staying at 80 when you reached there. Now you need to come back. So whenever you are coming back, suppose the value is minus 10. This edge's value is minus 10 because the direction has changed. You are coming from uphill to downhill. And suppose there is a mechanism that mechanical engineers has done it, that whenever it will be coming downhill, they will be somehow recharging the battery, refueling the battery automatically. Okay, because it will be, you do not need to do anything. It is coming downhill. It is kind of, storing the energy. It is storing the energy back. So it is minus 10. What does it mean? Because it was 80, now instead of kind of, eating up 10, it is giving you 10. So it should be 80 minus 10. That is nothing but 80 plus 10. That is nothing but 90. So if there is a negative edge weight, that simply indicates that you are gaining something. Say, instead of going via one path, if you are going via another path, you might get some cash back. Okay, instead of paying, say, via cash, if you pay to a driver via Google Pay, you might get some cash back. So that is the concept of negative weight in case of real life. That is the concept of negative weight. So there is a weighted graph and the weight can be positive as well as negative. In case of Dijkstra, Prim, Kruskal, whatever YouTubers, we have seen the positive weight. We will be seeing in Bellman-Ford, maybe in the next video, that is what is the concept of negative weight and how Bellman-Ford is tackling it. Okay, that is unweighted graph is done. What is cyclic graph? If a graph contains a cycle, this particular graph contains a cycle, so this is a cyclic graph. This is also a cycle, this is a cyclic graph. If a graph contains one cycle, that is cyclic graph, right? Now, because we know what is cycle, so that's why I've just said directly. Now, what is a acyclic graph? A graph that doesn't have any cycle. A graph that doesn't have any cycle. So what is that? If a graph doesn't have any cycle, so this can be a graph and it doesn't have any cycle, because if you're starting from one node, you cannot come back to that node, right? So if a graph doesn't have any cycle, that is known as a cyclic graph. Acyclic graph is nothing but what? Tree. So tree is a acyclic graph. So every tree is a graph and every tree is an acyclic graph. That is the thing you need to keep in mind, because every graph is not a tree, because this is a graph, and if a graph contains a cycle, tree doesn't contain a cycle. I'll be talking about these things in very depth whenever I'll be making a new playlist of all the data structures. But for the time being, let us just understand, if this a tree? No, because it contains a cycle. If it contains a cycle, it is never a tree. So every acyclic graph which doesn't contain a cycle, that is a tree. So every tree is a graph, that is every tree is an acyclic graph, but every graph is not a tree. Cool? Next is the last part I want to discuss before moving to the next videos, that is how to represent the graph. Suppose the graph is like this, A, B, C. So how to represent? There are two ways, adjacency matrix and adjacency list. If you see this graph, you draw A, B and C like this in the column and A, B and C like this. Now if there is an edge between two nodes, you put simply 1. If there is no edge, you simply put 0. So A and A, it doesn't have any node or something, 0. So A to B, there is a node, yes. A to C, there is a node, yes. B to A, there is a node, yes. B to B, no node. B to C, no node, 0. C to A, yes. C to B, no node. C to C, no node. So this is the adjacency matrix. This is the adjacency matrix for this graph. If the graph is given like this, you can form this. You can draw this. Or if the graph is given as this, you can represent it like this. Same way, what is the concept of adjacency list? Adjacency list is nothing but you can from this graph you can write it simply like A arrow B comma C, B arrow A and C arrow A. Simply means A is connected to B and C, B is connected to only A, C is connected to only A. That is, you are representing in terms of a list, right? That is A arrow, that is kind of a linked list. You can think like that. So this is all the concepts, all these terminologies and all these representations, when to use adjacency matrix, when to use adjacency list, whenever the graph will be say having a lot of vertices, the graph is completely connected, how to tackle those things, we'll be covering everything in depth. But for the time being, I just wanted you to know all this terminology clearly in your mind, so that whenever we'll be talking in terms of say the Bellman-Ford, Floyd-Warshall, things becomes more clearer. Right. So that's what I wanted to talk about and give you a complete graph intro and all the terminologies, all the representations. So I hope all the things, whatever I have talked about in this video, made sense to you. Thank you for watching and stay tuned for the next videos.